Hello everyone, I am Govindaraman, currently pursuing engineering degree in Sri Venkateswara College of Engineering in the Department of Computer Science with Artificial Intelligence. So in today's presentation, we will be studying about continuous distribution, normal distribution and many more topics. So let us look into the presentation and learn some of the important topics in data science. Introduction to continuous distributions. Continuous distributions are the fundamental concept in probability and statistics describing variables that can take on any value within a specified range. Understanding these distributions is crucial for data analysis and modeling in fields like finance, physics, biology, etc. Moving on, the normal distribution. The ambiguity of normal distributions is one of the most fundamental and widely applicable probability distributions in statistics. It arises naturally in many real-world phenomena, from test scores to height to measurements of all kinds. Symmetric and bell-shaped distribution. The normal distribution is characterized by its symmetric bell-shaped curve. This curve is centered at the mean and the spread is determined by the standard deviation, providing a visual representation of the distribution of values. The third is empirical rule. The empirical rule states that approximately 68% of the data falls within one standard deviation of the mean, 95% falls within the second standard deviations, and 99.7% falls within third standard deviation. This provides a powerful impact for interpreting and analyzing normal distributions. Moving on, let us see the properties of normal distribution. The first property is bell-shaped curve. Normal distributions follows a bell-shaped curve which is symmetric around the mean and decreases in density as you move away from the center. Mean median mode. For a normal distribution, the mean median mode are equal and represent the central value around which the data is distributed. Standard deviation. Standard deviation determines the spread of the distribution. Approximately 68% of the data falls within a standard deviation of the mean. So let us see applications of normal distribution. The first application would be quality control. The normal distribution is widely used in statistical process control to monitor and improve manufacturing processes, ensuring consistent product quality. The second one would be finance and economics. Many financial and economic variables such as stock returns and GDP growth exhibit normal or near normal distributions, enabling the use of powerful statistical techniques. Biological science. Characteristics like height, weight, and BP, that is blood pressure, often follow normal distributions, helping researchers understand and predict natural phenomena. Social sciences. The normal distribution is applied in these fields like psychology, sociology, and education to analyze and interpret data on human behavior and performance. Moving on, let us see the central limit theorem. The first is sample mean. The average value of many samples is also called as sample mean. Sampling distribution. The distribution of sampling means is also known as sampling distribution. Normal distribution is nothing but the shape of the sampling distribution. The central limit theorem states that as the sample size increases, the sampling distribution of the sample mean approach a normal distribution regardless of the shape of the original population distribution. This powerful theorem allows us to make reliable statistical inference from sample data. Sampling distribution, limit theorem. The central limit theorem states that as sample size increases, the sampling distribution of the mean approaches a normal distribution regardless of population distribution. Sample statistics. Sample statistics like mean, median, and standard deviation are themselves random variables that follow their own sampling distributions. Hypothesis testing. Sampling distributions are critical for testing hypotheses and calculating p-values to determine statistical significance of findings. Hypothesis testing and p-values. Let us understand hypothesis testing. Hypothesis testing is a statistical method used to draw conclusion about a population based on a sample data. It involves formulating a null and alternative hypothesis. Calculating the p-value. The p-value is the probability of obtaining test statistic at least as extreme as the one observed, given the null hypothesis is true. It helps determine statistical significance. Interpreting the p-value. A low p-value, which is typically less than 0.05, indicates strong evidence against the null hypothesis, leading to its rejection. A high p-value suggests that the data is consistent with the null hypothesis. Confidence intervals. So let us understand what is confidence intervals. Confidence intervals are statistical tool used to estimate the range of values where a population parameter such as mean or proportion is likely to fall. They provide a measure of a certainty around a point estimate. Interpreting confidence level. A 95% confidence interval, for example, indicate that there is 95% probability that the true population parameter falls within the estimated range. This helps quantify the reliability of a test. Practical applications of continuous distributions in data science. Continuous distributions such as normal distributions have n number of real-world applications in data science. They are used to model variables that can take on a wide range of values like height, weight, or income. In fields like finance, the normal distribution is used to analyze stock returns and assess investment risk. In healthcare, it helps researchers to understand the spread of medical conditions and plan public health interventions. Conclusions and key takeaways of this presentation is: in this presentation, we have explored the power of continuous distribution, the importance of normal distribution, and profound insights provided by the central limit theorem. We have also examined the critical role of p-values and confidence intervals in data science. By applying these concepts, data professionals can draw accurate conclusions and make informed decisions. Thank you.